Hi students, let's look at this question here, which is on vectors taken from the year 2008, paper 1, question 11. It's a modified version. So let's can do this proficiently. Now the equations of three planes P1, P2, P3 are given below. So respectively, and lambda and mu are constants. The plane P1 and P2 intersect at the line here. So you take P1 and P2 intersect the line, find the vector line equation L. I think that is pretty okay. What we could do is actually just use GC. Okay, so just list down line number one. Plane number one would be 2x minus 5 y plus 3z equals to 3, and P2 will just be 3x plus 2y minus 5z equals to minus 5. Okay, so this case here, what you use is from GC. Just bring out your GC and just key these two in. You have two equations and three unknowns here. So just bring out GC and key in polysimultaneous equation. Here, go to apps and we're just going to use polysimultaneous equation here. And we're going to simultaneous equation solver, which is number 2. After which we have 3 equations and 2 unknowns. Okay, we're going to press next then. Sorry, wrong. I'm gonna just, the main is simultaneous, so we have 2 equations and 3 unknowns. Right, then I'm gonna just key in the 2, negative 5, 2, negative 5, 3, 3, 2, negative 5, 3, 3, then 3, 2, negative 5, 3, 2, negative 5, negative 5. Okay, so that's what we do, and once you're done, then we're just going to solve it. So this will be our line equation here. What we're going to do here is essentially just know that this over here will be x, y, z, x, y, z on the left hand side, and the right hand side here, these are all lambda, so x equals to negative 1 plus lambda equals to negative 1 plus lambda, and this will be 0 plus lambda. Okay, so the line equation here would then be, or the L, R equals to negative 1, negative 1, 0 plus lambda 1, 1, 1, and this will be our first part. Done. Not too bad. So let's look at part 2 here. Now before we move on part 2, I just want to mention that this shouldn't be lambda because we already have lambda in the other equation here. So now just change it to any other alphabet here. So I'm going to use alpha instead. Now we are given the L contain plane 3. Find lambda and mu. So I'm not sure what's going on, but I'm just going to draw it out first. So this is lambda, this is L. Alright, so this is L and lambda. So just draw it out. This is L here. I know that L over here, the direction is given by 1, 1, 1. We draw it at 1, 1, 1, and the point here is actually negative 1, negative 1, 0. Okay, then this is plane 3. Now plane 3 contains L. So when we do this, what we're going to do is actually this is the normal here, and after which what we're going to get here is just normal. Yeah, normally the normal here, I'm going to write this in plane 3. R dot scalar product form 5 lambda, so it's just 5 lambda 17 equals to mu. Okay, so this is 5 lambda 17 for the normal. 5 lambda 17. Okay, now if the line is on the plane, so you can be sure if line is on plane, so the first thing you should know is actually the line is parallel to plane. It has to be parallel to plane, right? Now if line is parallel to plane, this will tell that the direction of the line is actually perpendicular to the normal. Okay, so that's where the first clue lies. So this is where if we take d dot n should be equal to 0. So if you look at this diagram here, you get this is the normal here and this is direction. If you were to dot it, so I'm going to draw a parallel line here. So if this is normal here, if I'm going to dot this, it will be 90 degrees to it, right? So it will be parallel to it. So it just looks like that. Maybe I should just draw it like that. Okay, so like that. There you go. Okay, so d dot n, we're going to just take 5 This is 1, 1, 1, 1, 1, 1, dot with 5, lambda 17 equals to 0. So this would be 5 plus lambda plus 17 equals to 0. So this is lambda equals to minus 22. Okay, so I got the first one. Now, after which, you should know that the point on the line will satisfy the plane equation. So the plane equation, let me just take this plane equation here. So I'm going to make a here what we're going to get is essentially plane 3. We're just going to sub a point in, which is minus 1, 0. So sub point minus 1, 0 is on P3. Okay. Essentially what I get here is actually just substitute into the Cartesian equation. That will be good. So that will be sub x equals to minus 1, y equals to minus 1, z equals to 0 into P3. So this case here, okay, is 5 times minus 1 plus lambda, which is actually minus 22 minus 1 plus 0 times 17 equals to mu. So mu will just becomes 22 minus 5, which that would be 17. Okay, so that's how you do this part here proficiently. Let's look at the part 3 there. Given that instead the line L does not intersect P3, what can be said about the value of mu and lambda and mu? Okay, that is pretty interesting. So now, part 3. If they do not intersect, there's only one way that it could be, right? Meaning to say, if P3 and line L doesn't intersect, means the line has to be parallel to the plane. Because if it's not they are not parallel to each other, you intersect at a point, right? So in other words, you're looking at here, this point here. So I'm going to just draw this equation like that. Okay. So this one, just draw it down. Looking at this point L, and this is plane 3. Okay. Now you realize that the equation is the same, so I'm going to put P3 as r dot 5 lambda 17. 5 lambda 17 equals to mu, and this point here is actually negative 1, 0, and this lambda here is actually just 1, 1, 1. Okay, now means if line doesn't intersect plane, okay, line L, so this will imply that line is parallel to plane. Okay, that is what we should be able to deduce. In other words, this one will tell you that actually the n dot d is still equals to 0, which if you use follow this reasoning here, so this will imply that lambda is equals to minus 22. Okay, but minus 1 is not on P3. So minus 1 doesn't satisfy P3. Okay, this is what we can write. So in other words, mu cannot be equal to 17. That is very, very important. This is what we can deduce. Essentially, mu equals to 17 would make the line on the plane, right? Because previously, when this point is on plane 3, you have mu equals to 17. So any value which doesn't give mu equals to 17 would not be on the plane. So essentially, you want the line not to be on the plane. Okay, so for part 3, that's how you reason it. Okay, so that's how we understand this part here. Okay, it's a bit confusing, I know. It's a bit out of a norm, but try and understand it from an equation perspective. You satisfy or you don't satisfy, it works as well. Now let's look at part. If the equation P3, 5 is 5 minus 22, 17, and 5. So this is plane number 3. we asked to find the shortest distance between L and P3. Okay, so now look at this one here. This is lambda. This is where lambda equals to minus 22 and mu equals to 5. So we look at this equation here. Lambda equals to 22, minus 22 is either of this, but mu is 5, which is this case here. Okay, so we're going to use this diagram, which is actually the plane is actually parallel to the line. They are both parallel to each other. All right, so this is what we're going to use later on. So we're going to find the shortest distance between L and P3. I think it's pretty okay. Just going to use magic triangle. So I'm going to just find a point on P3, and after which just try and solve it. Okay, so I'm going to draw a new diagram behind here. So we have got this line here. The line here is L. They're parallel to each other, parallel. Okay, here. And after which we have this is part 4, right? So this point here on line L, we had the point just now, which is minus 1, minus 1, 0, and the direction here is actually lambda. Okay, sorry, this direction here, this direction D, will just be 1, 1, 1, and this P3 here now is R dot 5 minus 2, 2, 17. This is 5, and what we do we just put the direction vector up here, and this will be normal of 5 minus 2 to 7. All right, a minus 2 to 17. Nearly got it wrong. So in this case here, what we need is actually we just need a point on the on the plane. So because now any kind of distance question, we can use this magic triangle. Okay, so just guess a point on the plane. So I'm going to let point A, which is 1, 0, 0, be point on P3. Okay, so you get 1, 0, 0, any combination. So this is actually 5x minus 22y plus 17z equals to 5, right? Any combination of x, y, z. So you can just, the easiest is a 1, 0, 0. Any combination of x, y, z which gives you 5 would be on the plane. So 5 times 8. So 5 times 1 would be 5, then 0, 0. Okay, that will be 5 total. So that's why 1, 0, 0 is definitely a point here. So I'm going to let B be this point here as well. Okay, anything that's no name, I'm just going to label it. So let minus 1, 0 be B. Okay, so essentially what we're going to do now is we have got this direction here. Now what we're going to do is essentially also to find the this is normal, and okay, so we're going to find this distance here. So just remember that we have this vector A to B and they have normal. The angle sandwiching between them is here. So if you want to find this length here, this will be adjacent. Adjacent corresponds to cosine, cosine corresponds to dot. Okay, so that's usually how I tell students to do. Just remember that. So the shortest distance, try not to memorize the formula. Yeah, you can, of course, but try to understand it. So this will be dot unit vector. You do not unit vector the hypo. This is n here. Okay, so what you can do is just b minus a. So I'm going to just take b minus a. I'm going to just minus 1 minus, so it is minus 2, minus 1, minus 1, 0. This is a dot product, so I am pretty chill with dot product. I think most of us will be chill with dot product here. It's 5 minus 22, 17 dot over the root of it, because you need to find, there you go. Okay, so then what you're going to do is just dot it 10 plus 22 over this is square root 5 square plus 22 square plus 17 square. 798. 798 square root 798. 28. So 798 divided by 9. Nope. 16. Nope. 35. Nope. What was it? Square root 798. 20, 36. No. Okay, I think that's it. 798. So this will be 12 over square root 798 units. Okay, so that's how you do part 4. That's how you do that. Then we're going to do part 5. Find the Cartesian equation of the plane which contains L and the point 1 minus 1, 3. Okay, this we've done multiple times as well in class. So now given the line and also point, we do find the plane equation there. This is part 5, is it? Okay, I think this is pretty okay. So for 5, we just need a plane which contains a line, and the line here, which is actually just this point. The point on the line will be -1, -1, 0, and this direction here is just 1, 1, 1. And we need a point here which is actually 1, -1, 3. Same thing. I don't really like when there's no name to my points. I'm just label this as C. So let's see B 1, -1, 3, because it's easier in the long run. So this is B, right? Was this B? This was B, right? Okay, so this is B. So find the normal will be BC dot with D. So BC cross D. Okay, that will be the normal of the plane. I just want to find this normal here. So I'm just going to take BC cross with D. That will give me the normal of a plane here, right? So just take it's like the Fleming left or right hand rule. You take BC cross with D, we just get the normal here. So anyway, this will just be minus, so this is 1 -1 3 C minus B, which is -1 -1 0, and cross with 1 1 1. Thankfully the cross product is with 1 1 1. That's not too bad at all. So this will be 0, it will be 3, cross with 1 1 1. That will give us 0 minus 3, 2 minus 3 minus 1 1 2. Okay, so this is it. And I'm just going to find P, D. Okay, this is, now we're going to find P, which is actually R, any point on the plane. So I'm going to use 1 -1 3, that with -3 1 2. Now this is where the exam techniques help, because I usually will tell students just substitute, this is my C. So you have another point here which is B, just substitute it in. Okay, it's a free point for you to check your answer. So if you don't get the same answer, 2 means you get to check. You see, this is 2, so very likely your answer is correct. So the plane equation would then be R dot -3 1 2 equals to 2. So the Cartesian equation here, -3x plus y plus 2z equals to 2. Okay, so that's how you do this question proficiently. If you have any questions at all, please let us know. Keep practicing, and I'll see you in the next question.